Hi, welcome to Team Enigmetrics. Flood has always been a serious issue, but as the overall climate around the world is changing, it's getting worse than ever. Attempts had been made before to solve this issue, but they either failed or partially succeeded. This is mainly due to their approach to solving the problem. Digital methods, renewed supply chain management, or only prediction-based solutions would only help to a certain extent. By the time these solution methods start to work, damages have already taken place. Ours is a singular solution with two parts. The latter part might seem expensive, but as we are dealing with lives, a long-term permanent solution is the only way. Our first part, AI-based flood susceptibility prediction and rural planning. In this part, we will gather climate data, real-time environmental data, and satellite data to train an initial ML algorithm. This AI model will produce a long-term climate overview. Then we will use land surveillance drones and geographical information system-based softwares to map the terrain. We will use that terrain data along with the climate overview to train another model, basically using backpropagation, genetic algorithm, and deep belief network, which will tell us about flood susceptibility. Finally, all this data will be fed into another model trained to calculate the most efficient water channeling pathways on the surface and the channel dimensions also. As we can see, this is your typical rural terrain beside a water body. As we mentioned earlier in our report, we will be working with such areas, dealing with pluvial flood, tidal flood, pluvio-tidal flood, etc. When the water level rises, water engulfs the total area. So we will excavate channels according to the calculations of our AI model. Now, if the water level rises, the water will travel along the channels. But to stop the water from rising upwards, we will be planting subterranean flood protection blocks or SFPB, which will absorb a significant portion of the water. Our placement of blocks will not only protect from flood but also river erosion. Then during dry weather, the stored water will vaporize and rise to the surface, keeping it moist. Now the question rises, how we will make these SFPB blocks. Similar attempts had been made before by a company called Termark. They made a concrete block called Top Mix Permeable, which can absorb 1000 liters of water per minute per square meter. But the material they have used is pretty costly. So for the material, we are choosing recycled plastics. Now the type of plastics will depend on the soil type of a particular location, which we will determine based on extensive research. The recycled plastics will first be chipped into smaller parts, which will then be melted. After that, we will add additives like UV absorbers, HALs, or hindered amine light stabilizers, quenchers, so that the plastic can sustain and not become brittle over time. Then we will harden the plastic and make fine pellets from them. These pellets will be converted into blocks by a process called sintering. The solid parts of the block will control the integrity and the void spaces will control how much water they can hold. So during the sintering process, we will try to achieve the perfect ratio between solid parts and void spaces. Similar plastic blocks have been used before in Gurugram, India in place of asphalt on roads to hold rainwater. But due to constant friction between tires and the blocks, microplastic pollution was rampant in the area. This is why our blocks will be subterranean. As this is a completely new idea, more research is required in the field of material selection. SFPB production can open a whole new world of possibilities. Thank you.